Eric Burgess here, and we have been confronted with a question. The average SAT score for the mathematics portion of the test is 511. In a recent study of 19 individuals that took the test, the average score on the mathematics portion was 519.3, with a sample standard deviation of 82.4. If the level of significance is 0.01, test the claim that the average SAT score for the mathematics portion is greater than 511. So we've been given a lot of numbers. We're testing a claim here, and that's how we know that we are going to be doing some sort of a hypothesis test. And let's just get the numbers out of this problem. First thing I like to do. So the average SAT score for mathematics portion is 511. So they're just stating this. They're saying that mu is 511. They're saying this for everyone. If the average SAT score for all people, 511. That is what they're saying. In a recent study of 19 individuals, so we have a study, that's N, that's 19, that took the test, the average score on the mathematics portion was 519.3. So the average score for them, now this was our sample, right? Our sample of 19 people, so this was our sample mean, and that's 519.3 with a sample standard deviation. So keyword here, we see we're using a sample, and so that's going to be S, not sigma, and that's going to be 82.4. And because we're doing a sample standard deviation, this will be a t-score. If the level of significance is 0.01, and that's pretty easy, that's just alpha is 0.01, test the claim for the SAT greater than. Okay, so now we've got our claim and stuff, so let's figure out our null and our alternative. So we've got a null hypothesis. That one's always got the equals to, so that's mu is 511. Right, that's just what they say at the very beginning. The null hypothesis is that the mean, the population mean is some number, in this case 511. Our alternative hypothesis, H1, is going to be, or HA, depending on your teacher, is going to be that the mean, and now if it's 511, we're testing the claim that the average SAT score for mathematics is greater than 511. So we think that the mean is actually bigger, so the alligator would rather eat the mean than the number 511 because they think the mean is bigger. And we also know that this is our claim. So our claim is this one, is the alternative hypothesis. All right, cool. So that's all good. Now for this next portion, we will be doing it two ways. We'll be doing it using the formula, and we'll do it using the calculator. So let's go ahead. Let's do the formula way first. I think that's the most common. So we need a couple things. We need our critical value. We need our test stat. And that's what we need. So let's go ahead. Let's get the critical value first. So I'm going to go ahead and draw out a normal distribution. And to get the critical value, first we'll do it using the chart, then we'll do it using the calculator. So our critical value is defined by an alpha of 0.01. And we know from our alternative hypothesis that the number of tails is one tail, because we have a one tail test, and it is a greater than symbol on the alternative. So the tail is going to be somewhere up here. This is going to be our alpha of 0.01. That's the amount of area that's there. And we need to find the test stat, or not the test stat. We need to find the critical value that would go here. So we say, okay, let's go to our t-table. So here's our t-table. And, we need degrees of freedom, right, for a t-table. So let's come back here. Our degrees of freedom is just 1 minus n. So degrees of freedom is 19 minus 1. That's just 18. So we come in here. We find 18. It's right here. And for a one tail, so that's this row, one tail, we want 0.01. So 0.01 is right here. So now we simply just go across and find out where they cross. So we cross right here at 2.552. So we're going to come into here and put down our critical value is 2.552. That is our critical value. If the test score is bigger than this, then we will reject the null hypothesis, because remember, in the middle is the null hypothesis. The mean is right here. And so we say, in this case, it's 0 because we're working with a standard normal distribution. And we've got a test score of this. If it's bigger than this, we reject the null. If it's less than this, and it lands over here in this safe region, then we fail to reject the null. We say that this appears like it could be true. So let's go ahead and do that. So that's our critical value. Now, if you want to get the critical value using the calculator, you're just simply going to come in and turn your calculator on. Now, this is a distribution. It's a standard normal distribution. So we're going to go to second distribution, and we are doing an inverse t because the t distribution is a standard normal that's just a bit different. So we're going to go to inverse t, number 4, hit enter. Now the area, that's going to be 0.01, that's just our alpha. Our degree of freedom is going to be 18. And we're just going to paste this in because that's all we need to look it up in the chart. It's all the calculator needs. And it's going to give us 2.55. Now it's negative because it's doing the 0.01 as if this area were on this side, as if the area were over here. But we know that this distribution is symmetric about the mean. So we just take the positive of it, and that's how you would know to make it positive. You would say, well, we're doing it for a greater than test, and so we need the positive version of this. You notice that also in the t-chart, it didn't give us plus or minus. Everything was written as just positive, but we would have to know to make it negative if it was a less than chart. So now we need to find our test stat so we can tell whether or not we should reject the null hypothesis or accept the null hypothesis and what to do with the claim that we have. So we need our t-score formula. So I will just remind you, you'll have to go look this up. You'll have to remember, oh, this is a t-score. So you go look up the t-score formula. It's going to be x bar minus the mean divided by sigma, in this case it's s, divided by the square root of n. And so this would be the formula that we're going to use. And if we plug these values in, well, from our study, we found that the sample mean was 519.3. So we plug that in, 519.3. We subtract off the mean, and our mean was 511. So we go ahead, we put that down. And then we're going to divide. In fact, I'll make this look a little nicer too. Look at that straight line. We're going to divide by the sample standard deviation. That is 82.4. 82.4 divided by the square root of n, which our n was 19. So we plug that in, and we're going to get a number out. Now this is of course using the formula. We'll do it using the calculator here in just a sec. So we need to type a fraction. So we hit the green key to get to the F1 menu up here. So hit this y equals. And we want the first one. And we're going to do 519.3. I explained that in a lot of other videos, so I'm going a little quicker here just because I tend to explain it a lot. Whoops, I do that a lot too. Minus 511 divided by, we need another fraction. So we just go ahead, hit green key, and then the F1 key. And then we do 82.4 divided by, we need square root. That's here in blue. So we hit the blue key, square root. And then this is just 19. We hit enter, and we get 0.4, and we're going to round to 2 spots. So 0.44. Some teachers have you go to 3, some have you go to 5, just depends. So this is our test stat. All right, now there's a couple other things we could get. Now let's do it using the calculator. So in the calculator, you just simply go to stat, come over to tests, and we want a t-test because we're doing a t-score stuff. So we choose 2, and we have statistics, so we're going to choose these stats. We don't have data, we have stats. So we're going to come in. Now for our mu naught, that's 511 from earlier. Our x bar is 519.3, so we put 519.3. Our standard deviation, SX, is 82.4, 82.4. Now you might be wondering, why do they have an X next to the S? That's because the S is determined by X, by our data. That's why it's there. And our N is 19, and it will simply go ahead and pop these things in our formula for us. Now it needs to have the alternative so we can determine the area, the critical value, and sort of this stuff. So for this, we have the mu is greater than 511. So we say that it is actually bigger. So in this case, it would be like this. I know it's written this way. That's because they wrote their mu naught on the other side. but mu is bigger than. So that's what we want. It would rather eat the mu naught. So we're going to choose that one, and then we hit calculate. And we get a t-score. Now look at that, same t-score. If we rounded 2 spots, 0.44, and we get a p-value of 0.66. So p is equal to 0.66. This is a very large p-value, and we'll talk about what that means here in a second. And then we've got 519.3 and all our data and goodness. But this is what we need. So now we can make our conclusion. So first, let's go ahead and graph the test value. Let's do it using the test value first. So 0.44 is going to be like right here, 0.44. And so we are well within the white region. We are not in the dark territory. And so we, because of this, we say we fail to reject or don't reject, fail to reject H naught. So we don't reject the null hypothesis. We're saying we're so close to the mean based on our sample that we did, the study that we did, that this is probably a true value. So we can't really reject it based on the criteria that we've given ourselves here. And now we need to look at our claim, because what do we say about the claim? So our claim was the alternative. And here, this one, we think based on this, we say, oh, well, this appears to be true. We fail to reject the null. If you don't reject something, you think that thing is true. So we say, based on what we have here, we think this is true, which makes this one false, because they can't both be true at the same time. So this one's got to be false. That makes our claim false, but we can't just say that our claim is false. What if our particular study just wound up producing this result? And if we did more studies, it was wrong. So based on the evidence from our study that we have here, we think that this isn't right. So we say we don't support this claim based on our evidence. So what we say is there is not evidence, because our evidence doesn't support it. So there is not evidence to support the claim. Remember, we can't just say that we just outright reject it, because what if the study that we did, this one time it happened to be like this, but if we did more studies, they could be right. So we just don't support the claim because we did not produce evidence to support it. And that is how you do this. Now, there's a couple other ways you could draw this same conclusion. We could use the p-value. And so if our p-value, if p is greater than alpha, then we fail to reject H naught. If it's less than alpha, if p is less than alpha, then we actually reject H naught. But we see here that p is greater than alpha, and you could even write it out. 0.66 is greater than 0.01. Now the way we would interpret this is this 0.01, that's going to be like, pretend the area is over here. So far we've gone 1% of the curve. Well, this thing goes 66% of the curve. It goes way out here, right? 66% of the curve is covered. So we are so far outside of this shaded region that we can use the p-value as just sort of like a test stat. We can say, hey, this p-value is so much bigger than this value that we are not in the rejection region. If it's smaller than that value, if the p-value, so here's our 1%, if we were smaller, like 0.001, we'd be somewhere in here, and we'd be well within the rejection region. Now I'm flipping it because it's easier to think like we're starting at 0% of the curve covered, and then 1%, up to 2%, 3%. But in reality, everything's been flipped over here, right? So it's actually going this way. But the same thing stands because the curve is symmetric. So we're able to do things like that. But the same conclusion would follow based on the p-value as well. So that's how you would go ahead and do a question like this. If you have any further questions, let me know. If you're a student at Citrus College, you can go to online tutoring, get some extra help there. We're there to help you guys. Subscribe, and we'll see you in the next problem.